All right, guys, we are in the last lesson of Unit 3 of Topic 3, so that's really exciting. And today's lesson is all about symmetry, which I know that you feel very confident in, so this is going to be a whole lot of fun. Three objectives for today. It says by the end of this lesson, I will be able to describe the rotation and or reflections that carry a polygon onto itself. We're going to predict the effect of a given rigid motion on a figure. So what do you think is going to happen? And then we're going to identify the types of symmetry in a figure. And there are three types of symmetry that we're going to look at. And they're listed right here. So point symmetry is one, reflectional symmetry is another, and rotational symmetry is the third. So let's go ahead and go to the end of our packet so we can talk about these, and then we'll be able to do the lesson. All right, let's look here. So the first type of symmetry we're going to look at is reflectional symmetry. This is exactly what you think of when you think of symmetry, okay? So this is the type of symmetry where if I could like fold it in half, right, it would line up on itself. So something like an isosceles triangle, right? That has one line of symmetry, and that's reflectional symmetry, right? We cut it in half and it folds onto itself. Same thing if I have like a little heart, right? I have reflectional symmetry, and there's one line of reflection. The only thing we want to make a note of here is that the line of symmetry, is always a dashed line. So that's just really important to note. Always a dashed line. So whenever we draw our lines of symmetry, or lines of reflectional symmetry, it's always a dashed line. Okay, so that's exactly what you think of when you think of symmetry. The next one is rotational symmetry. So this is a type of symmetry for which there's a rotation of less than 360 degrees that maps the figure onto itself. So I'm going to give this my best shot here and draw a pentagon. It's not the worst pentagon I've ever drawn, right? And if I have a point of symmetry in the middle there, if I rotate this pentagon like so, maybe I want to draw that dashed, right? So if I, hopefully it'll last through this video, okay? If I rotate this, it will line up on itself. And so the way that we find our rotation symmetry is we do 360 degrees because that's a full, right, all the way around rotation. And then we divide by the number of sides. And that will allow us to find our rotational symmetry. The last thing is point symmetry. And point symmetry happens when I have 180 degrees rotational symmetry. So if I have 180 degrees rotational symmetry, we say that the shape has point symmetry. So like, for example, in this rectangle, if I draw this line, right, if I rotate this 180 degrees, it will line it back up on itself. So we say that this rectangle has point symmetry. So those are the three different types of symmetry that we're going to look at, and we're going to learn how to identify shapes with. So let's go back to our notes and we can get started. Okay, so let's start with example 1. Example 1 says, what transformations can be used to map the figure onto itself? Okay, so basically, what types of reflection do we have? Or sorry, what types of symmetry do we have? So one that seems kind of obvious, right, is if I draw a line of reflection right there, line of symmetry, right, I can fold it in half. So let's call this line A. And then another one that's brought up is this one, right? And let's call that line B. And so these are lines of reflection where if I divide the shape in half, it'll fold back on itself. So because they're lines of reflection, we use a capital R. So we can say that we can reflect over line A, and we can reflect over line B. So those are two types of symmetry. I also have rotational symmetry, right? If I turn this 180, it will line back up on itself. So I can say that I can rotate 180 degrees around the origin. Let's call this point right here the origin. If I rotate 180 degrees around the origin, then it will also line back up on itself. So that's what I'm interested in. How can I get it to line back up on itself? Okay, so I want you guys to try these two. See if you can come up with all the different ways that we have symmetry in these two shapes. All right, so let's check your work here. I went through and I drew in our lines of reflection that I saw. And so here for A, I see that I have a line of reflection over A. I have reflection over B. And I also have rotation of 180 around point O, right? So I can fold it in half on line A, I can fold it in half on line B, and I can rotate it 180 around O. And that's it. That's all I have in terms of symmetry. For B, I just have this line right here. So I have reflectional over line A, and that's it. That's all I have. There's no rotational or anything like that. And then I want to make a little note here, because this does have rotational of 180, this is point symmetry. It has point symmetry. Just as a little note here. Okay, let's move on to example 2. Example 2 is just asking me to find how many lines of reflection or lines of symmetry are there. So I'm just going to start drawing lines, right? So here's one, here's one, here's one. So there's 3 so far, and then don't forget that we can go vertex to vertex, right? So there's one more, that's 4, there's 5, and there's 6. So we should have 6 lines of symmetry. So your lines of symmetry, how many ways can we just cut that guy in half? Okay. 2 try-its for you here. So go ahead and pause the video and determine how many lines of symmetry do these figures have. Okay, so check your work here. For A, we should have 2 lines of symmetry. We have that vertical line of symmetry and the horizontal line of symmetry. And then for B, we only have 1 line of symmetry. You can't go across the middle there because it won't line up on itself. Okay, so we only have 1 line of symmetry for B. And let's just keep on cruising. Hopefully this isn't killing you so far. Okay. Example 3 says, for what angles of rotation does the figure map onto itself, right? So this is a triangle. I can turn it 3 times, and every time it'll line up on itself, but I want to know how many degrees do I have to turn it. So let's make a little note here that 3 turns, oops, that looks like Tums, that's funny. 3 turns will get you back to the start. We'll get back to the start. Okay, so 3 turns will get you back to the start. So because of that, we can use that formula that we wrote down earlier in our terms. 360 degrees is all the way around. And then in this case, I had turned it 3 times to get it back to the start. So if I turn it, 360 divided by 3 is 120. So if I turn it 120 degrees, it'll line back up on itself. And then another 120 degrees gives me 240. And that will also line back up on itself. Okay, and then 360, obviously it will line back up on itself. So there are the 3 degrees to line back up on itself. Every time I turn 120, 240, or 360, it will line back up on itself. So I want you to try this with the next one. Okay, it says, for what angles of rotation does the figure map onto itself? So then the question is, how many times do I rotate it before I get it back to the start? Okay, how many times do I rotate it to get back to the start? Go ahead and try it, and then when you're done, hit play. All right, so let's check our work here. If I turn this 90 degrees, it will not line back up on itself. I have to turn it 180 before it will line back up on itself. So because it takes 2 rotations to get back to the start, I'm going to take my 360 and divide it by 2, which gets me 180 and 360. Okay, we got some more try-its here for you guys to practice this a little bit more. So I want you to try these two. When you're done, make sure that you check your work by hitting play. But it's asking, what are the rotational symmetries for the figure? And does the figure have point symmetry? So 2 questions to answer there. Give it a shot and then hit play when you're ready. Okay, so let's check our work here. For the first one, the question is, how many times do I rotate it until I get back to the start? And the answer is 4 times. I can rotate it onto itself 4 times before I get back to the start. So I'm taking 360 and dividing by 4, which gets me 90, 180, 270, and 360. Since 180 is included in that, it does have point symmetry. Okay. And then for B, how many times do I rotate it and it lands onto itself before I get back to the start? And the answer is just twice. So I do 360 divided by 2, and I get 180 and 360. And since 180 is included, it does have point symmetry. So hopefully we're feeling good. We just have 1 page left, almost done. We're moving on to example 4. Remember, you can always pause the video and take notes or do whatever you gotta do, okay? Example 4 says, what types of symmetry does the figure have? So we're just gonna go through and we're gonna figure out all the different types of symmetry. So the first one I'm gonna look at is reflectional symmetry. So I'm gonna ask myself, does this have reflectional symmetry? How many lines of symmetry does it have? And I can draw them, right? There's 1, here's 2, here's 3, 4, and 5. So there's 5 lines of symmetry. So 5 lines of symmetry. So it does have reflectional symmetry. The next one is, does it have rotational symmetry? And so the question we have to ask ourselves there is, can I rotate it onto itself in less than 360 degrees? And the answer is yes, right? Every time I move it here, that's 1. Right here, there's 2. Here's 3. Here's 4. Here's 5. So if I rotate it 5 times, I will get back to the start. So that tells me that I can do 360 divided by 5, which gets me 72 degrees. And then the next one after 72, right, I add another 72, which is 144. And then I add another 72, which is 216. And I add another 72, which is 288. And then I add another 72, which is 360. So I have reflectional symmetry and rotational symmetry. The last one is, do I have point symmetry? 180 degrees is not one of the 5 degrees that I can rotate this. So I do not have point symmetry. There's no point symmetry. Okay. So pause this if you need to. I'm going to get rid of it. And the last thing that we're going to do, you guys have 3 triads, right? A, B, and C, and you're just going to do the same thing. Does it have rotational symmetry? Does it have reflectional symmetry? Does it have point symmetry? And then when you are ready to go over them, go ahead and hit play on the video. All right, so let's check our first one here. First one, I have no lines of reflection. There's nowhere, I cannot, like that doesn't work, right? This doesn't work. Diagonally doesn't work. Okay, there's no way that I can draw lines of reflection here. So I actually have no reflectional symmetry. For rotational symmetry, if I use a point of rotation here, I can rotate 180 and it'll line back up, okay? So I do have rotational symmetry at 180 and 360. Since I have rotation symmetry at 180, I do have point symmetry. And those are the 3 types that we're checking for, so that's it, okay? If you haven't done the square, go ahead and do the square and then we'll go over it. Okay, let's look at our square here. So for our square, I have 4 lines of symmetry, right? That vertical one, the horizontal one, and then the 2 diagonals. So 4 lines of symmetry. I can rotate this 4 times and have it land upon itself before I get to the start. So I did 360 divided by 4, which got me the 90, 180, 270, 360. And since 180 is included in that, right, it does have point symmetry. The last one here is this star. So go through and see if you can find all the different types of symmetry in this star. All right, our last one here is the star. Hopefully we found that there were 6 lines of symmetry for this star, right? So if I just go through, and you can do it, and so on and so forth. 5, 6, right? So 6 lines of symmetry there for the star. And then the rotational symmetry was a little bit more difficult. I can rotate this 7 times before it lines back up on itself. Now, 360 divided by 7 is about 51.4, but not exactly. So these numbers that I did, right, 51.4, and then plus another 51.4, plus another 51.4, and so on and so forth, these are rounded. They're not perfect, but it gives you the right idea here that every time I add 51.4 degrees, this shape will line back up on itself. And that's it for our notes on symmetry. Hopefully this makes sense. If not, please make sure that you're reaching out to your teacher, asking questions, getting help. I know that we're moving very, very quickly, and so you want to make sure that you're getting the help when you need it. But that is it for topic 3. And if you have any questions, let us know.